This video is going to be about converting different types of kinematics graphs for one object to the other graph. So we have one object moving with the velocity versus time graph shown in the center here. Okay. So let's remember that using TSA can be very helpful here. Remember, T is the type, so you do Y versus X. So in this case, it's velocity versus time. The S stands for slope, which is always a change in Y divided by a change in X. So in this case, velocity divided by time, which we know is acceleration. And then we look at the area, which is always going to be a Y times an X, which in this case is velocity times time. Now it's not immediately obvious what velocity times time is, so let's take a look at the units. A meter per second times a second. If we put that second over 1, we see that the seconds end up canceling and we're left with a meter. So that must mean that the area, or the velocity times time, gives us information about the displacement. So we can use the slope and the area to help us fill in the other two graphs. So to fill in the acceleration versus time graph, we're going to use the slope at any particular second. And for the position versus time graph, we are going to look at the area at any particular second. So let's do the slopes first. So it looks like from 0 to 5 seconds, we have this nice horizontal line which represents a 0 slope. So for us, that would represent an acceleration of 0 meters a second squared. So I can kind of fill that in. It's going to lie right on the origin. Then from 5 seconds to 8 seconds, I have a line. Remember to calculate the slope. You need to do a change in Y over a change in X. So our change in Y is -3 meters a second. Our change in X is 1, 2, 3. So 5 to 8, 3 seconds. So that gives us an acceleration of -1 meters a second squared. So our graph for 3 seconds jumps down to -1 meters a second squared. And it looks weird, but that's exactly how it should look. From 8 to 12 seconds, we again have a slope of 0. So that goes back on the x-axis. And then from 12 to 15, again, we have a change in Y of -3, a change in time of 3 seconds. So that again gives us a slope of -1 meters a second squared. So we're going to jump back down to -1 here, and so on. Now notice that I didn't even pay attention to whether or not the velocity was positive or negative. I'm just paying attention to whether or not the slope is positive or negative, because the slope is what tells me information about the acceleration. Okay, so just to go over what this object is actually doing, keeping those accelerations in mind, from 0 to 5 seconds, we are moving at a constant velocity. That's what 0 acceleration means. From 5 seconds to 8 seconds, this object is slowing down. We have a negative acceleration but positive velocity. Since our acceleration and velocity are in opposite directions, we must be slowing down. From 8 seconds to 12 seconds, it looks like we are at rest, which is a constant velocity, which is why our acceleration is 0. And then from 12 seconds to 15 seconds, we're actually speeding up. So even though we have a negative acceleration, we also have a negative velocity. And if our velocity and accelerations are in the same direction, that must mean we are speeding up. So that's how to go from velocity to acceleration graphs. So let's go the other way, velocity to position graphs. So I'm going to erase all of my slope information since I don't need that anymore. Okay. But what I do need for position versus time is the area. So figure that out from TSA. Okay. So we're going to go second by second and calculate the total area to give us the total distance traveled in that amount of seconds. So in the first second, we travel this area, which is a box. Okay, so we apply our area is base times height. Our base is 1 second. Our height is positive 3 meters a second. So that tells me that we have been displaced a positive 3 meters. So at 1 second, I am at approximately 3 meters. Okay. Now with each additional box, since this is a nice constant rectangle, I'm going to travel an additional 3 meters. Okay. So at the end of 2 seconds, I'll be at 6. At the end 2 seconds, I'll be at 6. 3 seconds, I'll be at 9. 4 seconds, I'll be at 12. And at 5 seconds, I will be at 15. Okay. Notice how we have a nice line graph for the first 5 seconds. Remember, the slope of a position versus time tells us about the velocity. So if we have a constant slope, which we do from 0 to 5 seconds, that means we're moving at a constant velocity, which we are. Okay. So then we reach this section here with a negative slope. Now, just because we're slowing down doesn't all of a sudden mean we're moving backwards. This object is still going to be moving forwards, okay, just at a slower rate. Okay. So I have to calculate the area of this little triangle and this rectangle here to figure out how much distance, essentially, I gain from 5 to 6 seconds. So this triangle has an area of 1/2 base times height. So 1/2, my base is 1 second. Height, nope, not 3 meters a second, 1 meter a second. So that gives me a distance of 1/2 meter. And this rectangle, doing base times height, gives me 2 meters. So I've traveled an additional 2.5 meters. So if I was at 15 here, I'm now at 17.5, which is somewhere like here-ish. Then in the next section, I travel, well, this little triangle is going to be 0.5 again. This triangle will be 1 meter, so I travel an additional 1.5 meters. So that puts me at 19. And then this little triangle here has an area of 0.5, so that puts me at 19.5. So notice how my graph starts to curve downward from 5 to 8 seconds. Okay? That's because a curve represents a changing velocity on a position versus time graph. My slope on my position versus time graph is getting less steep, representing slowing down. And we kind of have a sad face looking curve, which means I have negative acceleration, which all matches with what I know. Then from 8 to 12 seconds, because my graph is on the axis, that means there is no area. So this graph just remains at rest for 4 seconds at 19.5 meters. Then we start to move backwards, actually. So once we get into the negative velocity, that's when my graph starts to move backwards. So from 12 to 13 seconds, I gain 1/2 meter, but this time backwards. So instead of being at 19.5, I'm going to be at 19. Okay? Then I gain 1.5 meters backwards. Okay? So instead of being at 19.5, I'm going to be at, what is that, 18? Nope, 17. Okay? Oops, 17. And then I'm going to gain another 2.5 meters backwards, which puts me at 15.5. Nope. What is 17? 17 minus 2.5. It's that basic math that I'm sometimes terrible at. And whip out my calculator. 17 minus 2.5 puts me at 14.5. There we go. So 14.5 is right about there. Okay, so notice I have another curve downwards. Okay, but this time my slope is increasing from 12 to 15 seconds, which means I am speeding up, which we are according to the velocity versus time graph. but I still have a sad face curve, which means I still have negative acceleration. Okay. So that is how we can take a velocity versus time graph and translate it into a position versus time graph and an acceleration versus time graph for a single object. We're just going to be using slopes and area calculations. The end.